a while.
Yeah.
Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Hello, everyone. and welcome to the webinar. My name is Bob Wentz and I shall be the moderator for this webinar. The webinar is entitled A Flexible Approach to Pumping Station Optimization, and it will be presented by Steve Barrett of Riventa Limited. At the end of the webinar, there will be a short time for questions and answers, but please note that the presenter's details will be shown on the screen during the Q&A session. So should you wish to contact them for further information, please do make a note of their contact details. During the webinar, would you also please post your questions using the Q&A button in Teams, and I'll go through them in order at the end of the session. Also, at the end of the webinar, I will put up a slide showing details of the next webinars that you can see after the end of this session. So thanks very much indeed, everyone. And I'd now like to hand over to Steve. Over to you, Steve.
Thank you very much, Bob. Good morning, everybody. A very warm welcome. I'm going to talk about how our wireless battery-powered technology has enabled us to provide a new service to our clients in the water utilities. Many pumps and processes are heavily dependent on turbo machines, and pumps are particularly important in our business. And measuring the efficiency of the machines is challenging. But that's what we specialize in. So we can really bring some clarity to what these machines are doing in service. We do that in three ways: measure, analyze, and optimize. Measure is the most important part because good data is what's required to make analysis and optimization possible and valuable. And so that's really what I'm talking to you about today. Very quick background. We've been doing this for a number of years, heading towards 20 years, specializing in water and wastewater. Our flagship technology is a thermodynamic pump efficiency measurement methodology and technology. We're currently operating in 13 countries and we're seeing a lot of different challenges and opportunities to improve operations, and we're sharing that with clients as we meet, and they're sharing their experiences with us. So pretty happy today to share some of these things with you guys. Driving down the pump costs is really key to what we do. Two main areas is reducing the energy costs through pump scheduling, how to make use of existing assets, make the best of what you've got already. And that's either being manual controlled or automated control, and enhancing what's currently being done based on what's possible from existing assets. The next part is the capital piece, where the capital investment may be on replacing pumps that are worn or refurbishing them or any maintenance. By improving that, by making that a data-driven process as well. So where the need is proven to the business case, and that leads to maximizing resilience and optimizing the maintenance planning process. So making assets perform is what we do. And our main kind of advantage of our approach is we have very high accuracy on-site efficiency measurement of these types of machines you can see on my screen. Advanced analytics helps us take that data and convert it into useful information, and then implementable recommendations is the most important part, where we actually turn this into reality and improvement. The new challenge back at the end of 2019 for us, we weren't aware of the major challenges that were heading our way with COVID, but at this point, how are we going to optimize 63 pumping stations across France? Over 280 pumps, various applications ranging from 35 kilowatts to over a megawatt. And the pumps and the system performance was unknown. So our challenge was to find ways to reduce the current £9 million a year energy cost of running these plants, identify pumps that need maintenance, so taking into account the condition and hydraulic performance, improve the sustainability of operating these plants, heading towards the net zero objective, reducing energy consumption and extending asset life, and red flagging anything that we find that needs to be dealt with. So we're working across France. You can see here, as many of you will have driven the 10 to 12 hours to go from north to south. It's a long journey. These are all the stations that we have to work on. So 61 pumping stations. As you can see, different colours for each group of stations in a particular area or charging zone, and basically we had to tackle those a station at a time in an orderly way. So the distribution of pumps in terms of size, not just geographical, but actually size, 30% of the pumps were between 35 and 135 kilowatts, and so you can just see here, the majority of the pumps are relatively small, a few very large ones, but quite a normal distribution of pumps in terms of size. In terms of optimizing the actual the project, if you can see here, we arranged them in 7 trips, 7 tranches. So each tranche was 2 weeks of work on site and 2 weeks of analysis. The biggest was tranche 3, which comprised of 44 pumps on 10 pumping stations. So we were going there in a week and installing each station, each of these tranches was achieved in a week of deploying the equipment. So generally we were able to tackle this in 6 months. This has led to us delivering a new service. So we've always done pump testing, and traditionally 1 pump at a time with a wired solution. And we also were involved with pump monitoring projects, again, permanently installed solutions, although latterly we're doing this as a wireless product. But we had to do a new service, so pump optimization service, which was brand new, where we deployed for 14 days. Wireless technology and battery power meant we could deploy quickly and safely across the pumping station. But this is the breadth of services and solutions that Riventa can offer, all the way up to network optimization, which is one of our latest offerings that we're currently moving into. So really, the breadth of what we do has been improved by wireless battery power technology with a very agile service that we now can offer. So 3 steps really for this new service: deploy, monitor and save. So deploy on the pumping stations, measuring each pump in parallel for a period of time. So monitoring stage 2, each of those pumps for 14 days, measuring efficiency, head, flow and power on each of the pumps, getting good granular data. And then we take that data, analyze it, produce a report of actionable things that can be implemented. This has all been made possible by this wireless technology that we have called Free Flow version 4. So it's very robust. You can install it in 1 hour per pump. Very accurate, better than 1%. Battery life, again, not relevant for a 2-week service, of course, but we can leave this technology on site for 5 years without touching it. Encrypted wireless comms and traceable to ISO 17025 for instrumentation standards. So very robust, very compact, and we measure everything through 1 port before and after the pump, so standard 1/2-inch tapping. So there's 2 ways of measuring the efficiency and performance of these pumps: conventional or thermodynamic. The conventional method, the downside with that is you need to measure flow. And measuring flow is quite hard to do because it's dependent on the geometry of the pipework. That greatly impacts the efficiency or the accuracy of the flow measurement. The thermodynamic method, you don't need to measure flow. We can calculate flow, but we need to measure temperature and pressure before and after each pump. That can be done with laboratory calibrated devices and sensors, which their accuracy aren't impacted by site phenomenon. So you get a high degree of certainty. So pump efficiency only requires pressure and temperature measurement. So it's really simple, very effective, and we've done thousands and thousands of instances of this type of work in various pumping stations from Australia to the Amazon rainforest. So just to recap, the wireless battery powered technology we now have just requires a 1/2-inch BSP tapping before and after the pump. From there we measure suction temperature, suction pressure before the pump, discharge temperature, discharge pressure after the pump. So very simple to do for us, very robust, measuring to 1/1000th of a degree, giving us per pump on individual pump efficiency, flow rate, head and power to a very high degree of accuracy. And you can make robust capital decisions off that, and you can optimize without better than 1% accuracy, you can optimize the process. So this is what it really looks like. So a 1/2 inch standard BSP tapping, which is found very commonly in the water industry. For that one tapping, we've got a little T-piece assembly that we measure temperature and pressure through. These are all digital sensors with the calibration constants in the sensor. And this is what it looks like in the field in reality. So, so you can imagine here, you've got your sensors. In fact, you've got 10 pumps on this site. There's no trailing wires. You're straight into the 1/2 inch sensor here, 1/2 inch tapping point. So you're measuring, those two give you efficiency across that unit. This then basically goes back to a data station, which is basically a suitcase that's mains powered, that's used for setup, and it's got 4G, 3G communication. So our consultant sat at our HQ can check the data while our technician's on site to make sure everything is operating as expected. And we can then check in on it over the 2-week period and take data. The cabinet door is open in this very clean pumping station to remind me to tell you that we also have a 3-phase power meter. Just having some timing issues. The 3-phase power meter that also measures speed in variable speed applications as well. So again, that's wireless and battery powered, self-powered, sorry, from the motor tails. And then all goes back to this unit. So minimal disruption to operation, very safe and very convenient. So if you've got a 4-pump station, 4 pumps, monitoring the hydraulics of each of those pumps, the temperature and pressure measurement, measuring the power to each motor, again, wirelessly communicated back to this unit here, and then 4G comms so we can grab data remotely as required. Leave this on site for 2 weeks is what we've been doing. So our methodology is plan, prioritize the stations. We did with this customer. He gave us a spreadsheet of all the stations. We prioritized them in actual geographical region here. We were doing 5 stations per week. So we were installing 5 stations in one go, and then measuring those, so deploying the equipment, measuring those pumps as they perform over a 2-week period. So we're getting 1 million data points on some of these stations over that 2-week period, but very high accuracy data, and again checked remotely by our team in the UK, remotely through 4G. Then you leave it to monitor for 14 days. We're logging every minute, all the parameters every minute. So we're capturing the current demand profile, the operation decisions, or what the control system is doing. So we can look at the benchmark, extrapolate that over a year, and then look at what's possible from the existing assets, as well as the opportunity for capital investment. And then we're reporting this data back to the client. And the most critical part is actionable recommendations. And that's really where this comes to. This is not data for data's sake. This is purely leading to, all these steps lead us to things that can be actioned by and with our client. So deploy the equipment, measuring the assets, and then visualizing some results. And that's what we've done on these 60 stations. The data challenge for us, this was a lot of data for us, a lot more than we've been used to. Quantity of data to analyze, so 6 parameters, 1 station. There's a lot of data coming here, and we developed tools and techniques to manage this data and analyze it effectively. Quality of data was assured. We've got a very robust measurement solution, and being able to access and see what's happening remotely with the 4G connection, which is available in most places of the world now, very easily, it gives us comfort that we're not losing time with some spurious event losing data. For us, the wireless technology has enabled us to do this in a timely way. We tackled most of this project in 6 months. COVID may have given us some delays here and there with travel, but we worked around that. We were able to work in an agile fashion. Collaboration is particularly important, and was with this project being in another country, and we work closely with our client to develop reporting and make it work, and it's been very effective. And I think it speaks for itself. The client is extending the project, which we're very pleased about. Communication, which is always a challenge. We wanted to avoid the poor guy in the bottom right hand corner here, who has so much data to look at and doesn't know where to look at first. And it needs to be more than pretty pictures, it needs to be actionable. So we developed a report format that was standard, agreed with the customer. Even the visualization was standardized. We then produced a protocol document which defined and gave a key to what everything meant, what all the parameters were, what all the graphs and charts meant, which you'll see in a second with some sample data I'll show you. It's quite complicated, and if you're not looking at it every day, you need a reminder. So a simple reference document was important. We developed standard templates as well for the reports, which enabled us to drop in multiple language. So we're doing this with different languages in different countries now. So probably most important in summary, all of the energy that we've tackled in each of these stations. And these are the paybacks we managed to achieve for this part of the project, excluding capital, pump refurbishment. We averaged 0.7 years payback for this project, which we're really pleased about. We gave a target to the customer of a year or less, and we safely hit 8.4 months, which he was very pleased about. And as we started to see those first few tranche results coming, he started to organise extending the project further. Of course, the savings that came off those projects are recurring because there are improvements in the way they operate the station. Okay, there'll be some intangible saving for extending life, which is more difficult to measure in the short term, but the electricity saving is very easy to measure in specific power terms, and that will be realised not just this year, but next year and the year after. We also discovered that 31% of the pumps that we measured had a payback period for refurbishment of less than 3 years, which is good to know, and the client is currently looking at how they manage and plan that with us over the next year or two. So this project here is about now a little bit of a deeper dive into a particular project in Paris, where we're feeding. This is a station that feeds Disneyland Paris with SOAR, which is one of the largest private utilities in the world, based in France. So 6 pumps, a couple of different sizes, 425 kilowatts and 110 kilowatts rated powers. And this is the sort of basic data we were achieving here. So as you can see, it's quite complicated without the key. So I won't dwell on this, but what we were able to do is reference OEM data with our measurement data, and then give some good engineering data and a very simple traffic light summary where we take into account, the pump hydraulic efficiency shortfall, current compared to optimum, and then vibration levels, giving a condition score. And then we take all of these parameters together to give an overall score of 1 to 5, 1 being big problem, 5 being very healthy. So we're able to give a very quick reference for the customer to understand the condition of their pumping asset. Then we're looking at holistically at the whole station. Here we discover this is this operating point for the benchmarking period, where we're looking at what the pumping station was doing over the 14 days we monitored the data. And then we've got the scheduled savings and what that will deliver in terms of savings. So a variety of flow rates, a variety of cost of operation, and what we're able to do here is quantify this aggregated saving here. So some big savings, averaged to 21% over a year. So this was the theoretical, what we expected. We actually delivered to the client a 25% saving. So we delivered more when they followed our, so the estimate we did was a very good estimate, but they actually managed to save slightly more, which the customer was very pleased about. We're doing a webinar on that case study later this month, and we'll publicize that if you want to know more about that and get into more technical detail. So in summary, our project, this new business model that we're able to adopt, its planning and collaboration was critical. It's an innovative new service. Clearly there was teething problems at the beginning. The client knew this was a new service, and it worked remarkably well. The technology was very robust, and we managed to get good results every time. And so it was a very good, successful project for everybody involved. It was only made possible by wireless technology. Battery powered, wireless, quick deployment, so 1 hour per pump nominally. Because we did the site survey, all the prerequisites were in place, the tappings were in place for the hydraulic measurements. We understood if it's high voltage or low voltage. so we had the right equipment. We knew if it was variable speed or fixed speed, so we could get all of those things right. We went to site, it was a quick and efficient deployment and safe. There was no operational impact because it was well planned, and we're leaving the station equipment in there for 2 weeks. So we didn't have to change operating conditions. We could just install the equipment and naturally see what the station did over the 2-week period. So very, very low impact. Because of this well-planned site survey before and rapid deployment technology, there's less on-site time for our engineering staff and our clients' engineering staff. So it's cost efficient, light on resources, and also, increasing safety. So this was only made possible by the wireless technology, and we'll be very pleased with the results we're getting from this project, and we're now deploying in other places. Then we identified plenty of actionable insights. So the primary, most measurable part was how we can look at what the control system was doing today versus what the optimum pump operation would be for various demands. And we were able to give the control system company the optimum schedule so they could enhance the current control system, which the client was very happy to do. Or where they're manually controlled sites, we're able to give a much more clear optimization plan for the operators to meet demand at least cost. So that was very effective. Benchmarking exactly what was happening today and what's the best possible from the existing assets. So that was really successful for the client. So the operators can see what they're doing today, they can see the benefit of this new data, and they can monitor and manage that going forward and get good results and be part of that process. We were able to then identify and prioritize the business case for capital projects. So 31% of these sites had pumps with a payback of less than 3 years for replacement or refurbishment of the assets. We identified some red flags where the pumps were operating at less than 50% or a long way from best efficiency, which was going to massively impact the life of those assets. So we were able to highlight those with the customers. They could prioritize those in the short term and make a 2-year plan for tackling the other stations in a timely way. So they knew that every dollar they were spending, every pound or euro they were spending on pump refurbishment, there was a strong business case. They knew what they were getting back for their money. The return on the project, the target we always set ourselves for these types of projects is less than 12 months. Although the pumps were quite small, some of them 35 kilowatts. So the cost of the service becomes a slight challenge in those stuff, but we're pleased to say we achieved 8.4 months for the overall payback of the project. And that's based on operational savings rather than the less tangible benefits of pump refurbishment and red flag events that we were able to flag up. As I said, this client has extended the project into 2021. We've got another 30 sites we're currently working on and planning as soon as we can get into the country. So we went and did the site survey of all 30 sites before lockdown occurred, and we're now ready to deploy now lockdown is coming to an end. We've now deployed this equipment based on the last 12 months in 6 other countries. In the USA, directly to customers who are able to deploy and want to do it themselves, sending data back to us through 4G communication. And we've got partners in other countries that are now deploying this to their clients, and we're working together in Singapore, Malaysia, the Philippines, Australia and Brazil, delivering these services without the UK Riventa engineers having to go to other countries. Although they like to travel, they haven't been able to in the last 12 months, and this has been a really good alternative. So thank you very much for your time. As I say, I'm very pleased to be here today, and thank you to Bob and his team for inviting us. We are doing a webinar on the Val d'Europe case study where the client will be involved and the client will take any Q&A. It's always better to talk to the client than the vendor. And I'll be happy to take any questions now or after offline at s.barrett@riventa.com. So I think, Bob, I'm timely, am I? Am I on time?
You are indeed, Steve, and thank you very much indeed for doing that. Could you put your last slide back up, please, Steve, with your contact details on? And yeah, if we leave that on the screen for everyone. We've got two questions for you, Steve. The first one is, does the tapping need to be on the side of the pipe or can it be on the top?
Yeah, it can be on the top. So the ideal tapping location is somewhere in the vertical plane, but we've done many successful tests with it on the top. So yeah, it absolutely is generally fine. We also like to be at least 2 diameters away from the suction flange and 1 diameter from the discharge flange. In an ideal scenario, if there's no tappings, we tend to mark the ideal, but we generally try and assess and work with existing tappings, and our engineering team have got a lot of experience and we can advise, but yeah, we always prefer to use existing tappings where possible.
Thanks very much, Steve. Somebody asked the question as to whether or not the presentation is available after the show, and the answer is that a recording of the webinar will be posted on the Pump Centre website. So for all of you that would like to view that again, please go and view that, or get in contact directly with Steve if you have any questions using the contact details that you see on the screen. Another question for you, Steve. Will this system be able to measure the maximum and minimum flow rates the pumps are capable of?
Yeah, good question. So yes, it will. I mean, we have no range issue. So as hydraulically what the pump is capable of, yes, we can measure both ends of that spectrum. So that's absolutely not an issue. So the technology itself, it works on a very wide range of pumping conditions. So and I guess there may be some limits at, you know, when you get very close to closed valve, but what we always measure is what's really happening in the machine. So I suppose at the very extremes, you might get some instability because the pump is in a distressed situation, but for the purposes of understanding what the capacity of the workable capacity, I would say yes.
Okay, and we've just got time for one very quick question, Steve, which is, what is the useful life of these temporary pump monitors?
So that's a really good question. The sensing technology that we use, we've been using it for nearly 15 years, and our first installation in 2007 is still working today. Since then, we've moved on with digitization of the probe and integrating that into the sensor itself. But the measurement technology that we're using, the principles are the same. We've just enhanced what we're already doing and moving to more robust integrated circuits, and that's led to more reliability and certainly more repeatability. Our temperature probes, now we put a useful life on them of 10 years. We tend to say that we can fit and forget our technology for 5 years. Some clients like to do calibration periodically, and we would always recommend, you know, at least every 2 to 5 years you do a service exchange, but we certainly have a useful life of this equipment of 10 years.
Okay, thanks very much indeed for that, Steve. Thank you.
Pleasure.
Yeah, I'd just like to, as I say, thank you very much indeed for that excellent presentation, and thank you everyone for attending. Do remember, if you've got any follow-up that you'd like to get in touch with Steve about, please do make contact with him, and also visit the exhibition stand in the exhibition hall. I'm going to show the next 2 sessions on the following screen and hope that you'll be able to attend them. But in the meantime, thanks indeed everyone for your attention, and goodbye for now. Thank you.